Hello, everyone. Hello, Ricardo.
Hello, Abe.
How are you?
I'm doing well, thanks. And you?
I'm fine. Yeah. We have a bit of time to play again with OpenRNDR, and we decided before to go for this one. It's a bit similar to the one from last time, at least in the aspect that it's a grid, and
Grids are very common.
yeah. Actually, in these 70s artworks, many are grid-based. And I was thinking of starting showing something that I like. Do you know this? That you can type Aura and it makes a program?
No, what is this?
I don't even remember what it is. I have to look in my settings and if I find it.
Is it one of those live templates?
Yes. Here it is. It's settings repository. And you can add one here by clicking the plus, and then you add this URL. Well, I don't know why I added my own, but actually there's one official one from OpenRNDR, which is the one you should probably add. I guess I was customizing it in some way. So it's very convenient when you want to start a new program. You just create an empty Kotlin file, and then you can type ORA, which is Open Render Application, and hit tab, and then it is there.
Very useful. I usually just copy and paste a template file that I have lying around.
Yeah, I used to do the same. Yeah. So I just wanted to show that shapes is by default enabled, which is what we need for making a grid. So we could create a grid. No, I'm a bit rusty. I haven't been programming in Kotlin today. What do we need? Well, grid is equal to drawer bounds grid. And we can specify how many columns and rows. This is what we did last time, and we could flatten it. And yes. I just wanted to make something very basic. So what could that be? Grid for each. Just draw a bunch of circles, maybe, on the center of each of those rectangles. So that would be drawer circle, and that's going to be the center of the rectangle, and this is the radius. But I think this shows something interesting, which is even if it's a grid, it doesn't have to look rectangular. It's just you have rectangle objects and you can do anything you want with them. So you can query the top left corner or the bottom right or the center or whatever you want to do.
Exactly.
And we were lucky.
Amazing.
So let's look at our inspiration. We want white background, black borders, and then let's see how we can shift. I still don't have an idea. Maybe you have an idea.
Yeah. Well, I guess now you would substitute the circle for rectangle.
Right. So rectangle, and we could just draw it just to test what happens.
Yeah, what happens? What are the dimensions there?
So this is automatically taken by, since we specified that we are creating a grid out of the drawer bounds, and we have 8 columns and 8 rows, then we get this. But
yeah, it is a rectangle already. Okay, yeah,
right,
of course.
But it's kind of deformed, and the original has squares. So instead of specifying how many we want, we could specify width and a height. And this changes what it does.
Just for the by the type, it knows already.
Oh, a lot. I think we need some padding or some margin. So it would be cool to specify both the amount and the size. But okay, what do we have here? I think this is the margin. at least we have some space around it. And okay. And I think one interesting, I think Edwin doing this. If we don't want these lines to be double, we could overlap them a tiny bit by changing the gutter value. So the gutter value is here, and I mean, if we give a positive value, then we add some space. But if we add some negative value, then they will overlap, which I found it interesting. So this is adding space, and I don't know what would be then -2 or -1. And then, see, no duplication.
Oh, wow. That's pretty neat.
Yeah. Great.
Perhaps we should just simplify and make the whole application square.
Yeah. You mean the canvas, no?
Yeah, exactly. Just make a 720 by 720, for example.
Yeah. Right. And yeah, now we have a square. Good. So now we don't want to draw the rectangles as they are, but we want to displace them.
Mm-hmm. Should we take a look at the original one and see how many squares?
Right. Those 4, 6, 8. Well, it's a bit like about 10 or something like this.
Yeah, let's do 10 by 10 then.
Well, in that case, we could, if we want to count, we can just again go back to integers. And since we are working with a square canvas, then it should be all right. Yeah.
Yeah, looks good.
So we need to apply a transformation before this, right?
Yes.
And
we have to rotate each of them individually, and I guess towards the center they start rotating more and being displaced, right?
Yeah, right. The strength of the displacement is stronger at the center, and it weakens as we move away. Mm-hmm. So I could already calculate something we're going to need, which is the distance. What is this? Machine learning assisted completion. What? I'm really not sure.
Maybe later.
So we're going to need the distance to the center. This to center. And this is going to be the distance from this distance to drawer bounds center. So this is the center, the distance from each rectangle to the center of the canvas. And yeah, we will figure out what to do with this later. Should we look at the guide to find out how to displace things?
Well,
or you remember?
So we're gonna, if you calculate also the main diagonal, like from the top left rectangle, like the first rectangle, if you calculate the distance of that towards the center, that will give you the maximum distance, right, of the possible. And let's say that between 0 and that distance, if we then normalize it to 1, we can then just get a random number and get also and from that like get a random. So that will scale, right? A random rotation.
Yeah. Then,
yeah.
I do this sometimes, and other times what I do is how to explain that. For example, I would calculate the amount, and I would say the amount is 50 divided by 1 plus the distance, or something like this. So when the distance is 0, we get an amount of 50.
Mm-hmm.
And when the distance increases, then the amount gets weaker. But of course, this is then you have to play. Maybe you have to multiply this by some factor, like to play around. But yeah, we can do it.
Yeah, if you use the first one, then you just have to replace 50 by that.
Yeah, I just wanted to mention that there's these two approaches.
Yeah, trial and error.
So the diagonal, what would be the max distance?
You can actually use the. I wonder if this is in ORX, because in my environment I do have a diagonal method.
Well, it would be actually. Let's see. The max distance might be the upper bound center. Is there a length? That's it.
Well, half of it.
Well, this is the distance, the max distance from the center to the top left corner.
So now it's the center vector.
Yeah, the distance from the center to.
Okay, right.
So this is, we can just divide distance to center by max distance. This is normalized.
Mm-hmm.
Then wait, when is maximum and minimum? So yeah.
Well, now you have a value between 0 and 1.
Right, but when is 1 is when is 0. I think I have to invert it, or. So yeah, I was just thinking that the distance increases as we get away, but we actually want the strength to decrease as we go away.
Yes.
So then, how do you write strength? Strength? No.
Strength, yeah.
This to center. So the strength will be just the inverse. So this way the strength would be maximum at the center of the screen and minimum at the top left or on the corners.
Right.
Okay. So this is a number we need.
We can test it with color, for example. Just make it gray.
So drawer.fill equals RGB strength. And I hit Alt Enter to load that. And let's see if we got it right. So here would be white, and black.
Makes sense.
It's not pure black and white, but I wonder is that expected? I mean, I like it like this. But
then it's because the values are smaller, right? They're not a full range.
Mm-hmm.
Which means that max dist is actually because max dist is from the top left, right? And we're comparing to the center of the rectangle.
Right. And
so it's actually smaller.
Dealing with the canvas and not with our. It doesn't take into account the padding. Yeah.
Yeah, exactly.
Well, I'm gonna leave it like this for now, even because we can then adjust the numbers to make it look good.
Yeah.
And so now, how do we displace everything? We can just do translate and rotate. No, that's the simple.
Yeah, let's write the drawer.isolated and start.
We can just try first just with rotation, which is in degrees. And as you were mentioning, we need this isolate. The reason we need to isolate, well, maybe you can explain it.
So the way that we deal with rotations and translations is via matrices, and basically what we're doing with isolate is the isolate has a context, right, which is isolated from each iteration. So we're basically rotating these matrix transformations. They are rotating or translating the whole canvas and not the actual shape, right? So we need to do it individually, or else it will have a compound effect. Right. You rotate the first time 10 degrees, and then the second time you want to rotate just 10 as well, for example, and it will actually add to the previous 10. Yeah. And
then probably all the squares will be like out of the screen or somewhere.
Yeah.
Far away. I could just try this for now. Like,
so now you also need to translate the canvas to the 0 vector, right?
Right. So we don't want to draw the rectangles. Well, actually, we need to translate to the centers. So drawer translate it.center. Then we rotate, and then this will be at 0, 0. But we can take the width and the height. And wait, we should draw from the center, right?
The rectangle should be itself on the 0, 0, right?
Yeah, that's why
I want to move everything, right? And then zeros. Yeah.
My only issue, let's try this, is I think because we draw from the top left corner, then this is going to be wrong. Yeah, how we can take into account the margin. But I can also just quickly, to make sure that we get 0, we could subtract some amount, and then what is it, squares at least 0. So just to make sure that in the corners, it's on the borders is 0, the rotation.
Maybe remove the fill.
The fill, yeah. Fill is gone. Almost. It's similar. But do you see what I mean that is not centered? Is because these rectangles are not drawn on the center of the center or where we want it. But by specifying here these coordinates,
then translate the corner.
Yeah, I can translate back half of this amount.
No, instead of translate it center, if you do it dot corner, shouldn't that be then the?
But we want it to rotate around the center, probably, no?
Oh yeah. Oh, yes, the rotation will be affected.
So then, if I do with, or actually, no, what's their center?
Dimensions, I think.
That's it. Because that's half. And now it should be on the center, everything. It's a bit unintuitive, maybe. Oh, I messed it up.
Yeah, this is the thing I was talking about.
I see, yeah. It's the half of the dimensions. Dimensions 0.5. Yeah. So now is centered and we have the right effect.
Very nice. It actually already looks quite interesting.
Maybe we can quickly go into, I can explain what I was doing here. The issue is because we have some padding, then all the squares were rotated. This strength was never 0. So if I subtract some amount, then I make sure that it's going to be 0. But the problem is it can be also negative. So then by adding these squares at least 0, then it's like clamping the value. So it's never going to be below 0.
Makes sense.
Yeah. And if I wanted now, I could make the effect more extreme, and still in the edges it should be 0, and on the center it should be a stronger rotation.
Yeah.
Yeah. Okay. So
now we need to randomize a bit, and also we will want to displace them.
Yeah. So the first thing, we could do the rotation. Instead of being 40, we could do what you mentioned last time. We used random isolated.
Dot isolated, yeah.
Random isolated. A lot of isolation here in this program. And then what would it be? Random double?
Or a Perlin for the position.
Well, Perlin, if we want to be some similarity between, we can look at the original, but we can try both. But I think in this one is more like random.
Yeah.
So
I don't think Perlin noise was invented by then, was it?
right, it was 80, maybe 80 something. I think when the movie Tron was
exactly.
released. Yeah.
Mm.
So double, we could do what, like between -60 and +60. It's funny that now specifying random is optional because we are in this context.
Exactly.
Ooh, wait, this is not random at all. What's going on?
I think the isolated needs to be outside of the.
Right. We are isolating. Yeah, for every rectangle, so they all get the same value. So let me adjust this. And now, yeah, it's cool. I like it.
Yeah.
Let's try with Perlin.
It's rather weird. you chose the 60 between -60 and 60 degrees.
Well, this could be any number, I guess, depending on how subtle. Like if we wanted full rotations, then we could do this.
Actually, the interesting thing would be, we can just rotate a little bit. Yeah, I think
also, I like it
ridge,
also.
Yeah.
It's like there's been an earthquake or something.
It's also nice because they are overlaid on top, right?
The top is kind of messed. We could take a tiny detour and we can just improve the rendering. How is that with this multi-sampling? Equals window. How was it? I thought it was window multi-sample or
try multi something. No,
I have to put the mouse on top and sign window multi-sample. I don't know why it's not. It was not doing it right. Sample count 8. So I think they should add anti-aliasing. Yeah, looks much better. Well, I don't know if you can appreciate it over the network, but yeah,
slightly improve. I think if we look at the original, the rotations are not that high, right?
Right.
Perhaps even less than the 60 at first, like 30 or maybe 20 even.
So we could specify here max rotation, and we use it here.
Yeah.
More subtle.
But also now we can play with the displacement.
Yeah.
We still need to move them around.
But before that, I wanted to try what you mentioned, the noise. Instead of using random.
Okay.
I'll duplicate this line, comment it out, and then instead of random double, we can do random. What was it? Simplex noise, for example.
Either that or Perlin, and then the position.
And then we can use the position, which might be, for example, the center. And because they are very high values, we should reduce this. Otherwise, it's going to be very random. And then
you're scaling the noise now, yeah.
Yeah. So now these numbers we're getting now, they're probably between -1 and 1, which is very small degrees. So we can now multiply it by the max rotation and run it, and let's see what happened. Is still, I don't see this. I'm gonna make it more extreme, and the max rod to be sure that this number is correct. I think it has to be smaller.
I think the issue is that with random numbers we might be getting a lot of low values, right?
But why are they similar to the neighbors? Maybe they
That's
are.
big.
If we make smaller squares,
Mhm.
we may see the pattern. So let's see with 20. Yes. Also nice. Okay.
It actually doesn't look very organic at all.
No, but it's interesting. Okay. So back to the random. And now we want translation. So maybe
Yes.
how do we
Perhaps the previous one, draw translate. So now you're centered, right?
right?
After
So we could add here some offset, no?
I would go on the last translate. After that, actually, if you add another translate, that would be just some random offset, right?
You mean a third translate?
Yeah. To make it really easy and clear.
Yeah.
So now you just have to jitter. Yeah, how?
So we can use again the simplex.
We can use simplex V, which is the vector version. I don't know if it's in this random singleton.
Right. We need two simplex.
No, but or you get two values, two different values, and you offset them. Yeah, maybe let's do like that, and then you offset them.
And now I'm not going to do this. I'm going to have a much bigger value, so we get a like random effect. And this is not going to be a max rod, but max offset.
Yeah.
And I'll add that here. I don't know, 100. Let's be extreme. And and the same for the Y. But we don't want exactly the same number. So I can just try, I don't know, by either. Can we swap them here? Yes.
Usually cool. Or that. Yeah, exactly. But keep the same scale, no?
Yeah, okay.
For now.
Yeah. So, and this gives simplest gives positive and negative numbers, so we can translate in any direction. Let's look at what kind of mess comes out of this. Pow!
Yeah.
Okay.
Well,
so
the thing is that now are you multiplying by strength? No. So everything is getting translated in the offsetting part.
You're right. Right. So we want the strength. So we can do this.
Should look a bit more tidy.
Yeah. Totally. Okay.
Yeah.
And what should we do? More subtle?
You also should let's return to the 10 by 10 grid.
Yeah. 10 by 10.
I think it also changes a lot the result.
Yeah. And should I reduce this a bit?
Yeah. Cut it in half.
Let's see. Okay. Let's compare.
I think the only difference is that it's doing like distance vertical and horizontal, something like that. It's more like a ellipse, right?
So there's another difference, which is they don't have a fill.
And And also, I think we should keep a bit of the unclamped part, because all of them are kind of jittered a little bit. Right now, we have some squares which are really fixed.
And what do you mean? That all of them should be a bit affected?
Yes, exactly. Makes it more interesting because some of them are quite fixed.
So what if I reduce this a bit? Whoa, that was not a bit. So how much? 0.4? Maybe you should have a GUI with some sliders or something.
Yeah.
Okay, I think we have to play with both numbers. And actually we could be doing live Olive.
Yeah.
Is that, how do I do that? Is that Olive program?
Yes.
Olive program. Because then we could do live coding. Let's see if it works.
Fingers crossed.
Yes. So we have it here. Now I'm gonna reduce this to 1 and save it. And oh yeah, it just took a while.
Something else we can do is that if we keep the strength at between 0 and 1, we can use an easing function and reshape it so that it's not so how do you say, so uniform.
You mean the
that
whole...
That already looks better. Yeah, perhaps because we want a bit of rotation at the edges, right? But we also don't want an extreme rotation at the top. But you're kind of doing that right now, right?
Yeah,
changing the curve.
It's by changing those two numbers.
Yeah.
You can... It's maybe not very intuitive, but this is like the overall effect. And this is the... As I reduce this number, then they are all more affected. But I'm just going to play for a second. Let's put the mouse instead of the center. How hard is that? I'm going to close it for a moment. We are calculating the distance to the center. So here we could use the mouse. Mouse position. But then it's no longer distance to center, but whatever. No, the name is wrong. Distance to interesting point. Oh no, I didn't rename all the instances. I'm not sure. Is that enough? Do I have to change anything else? Let's see if it's now interactive.
Let's hope they are in the same space, the same coordinates.
Yeah.
Nice. Now this they didn't have it in the 70s.
No, that was impossible. Both the live coding aspect, because I think they were doing punch cards, and I guess they had to think very carefully before typing any code.
And debugging paper and pen.
Yeah. Yeah.
Cool. I kind of like it when it's in the corners.
Yeah.
I think it should offset a bit more in the center. They're not moving much.
More offset, right. The offset is this one. 75.
Interesting.
Okay.
Did you remove the fill? Or is
yes. I did remove the fill because the original also didn't have fill.
Okay. Could you try with the fill? Just to see how it looks like.
Yeah. That's how we had it before. Where is the fill? Fill null. White. Yeah, it's also cool.
Yeah. Personally, I prefer this one.
Since we are playing with this, we could also show things like opacify. So now it's going to be, you see a tiny bit through, which is also cool.
Yeah. Like a paper sheet.
Yeah. Okay. So maybe it's a good duration not to make the video too long. What do you think?
Yeah, I think it's we got the main gist,
Yeah.
and now it's just a matter of tuning to your own preferences.
Yeah, right. But
Cool.
I'm happy with the result. Yeah.
Yeah, it's interesting. And a very simple algorithm as well.
Yeah. I'll show the code again.
Perhaps at a certain point we should put them in a GitHub repo.
Yeah. So it's not that long. It doesn't, with this font size, it doesn't fit on the screen, but yeah, it's rather simple.
Nice.
Cool. So very nice to do this again.
Yeah. Let's keep it moving.
Yeah,
And,
let's see next time what. I think we should find other sources of inspiration.
Perhaps we should go come to the present and
Yes.
find out something simple.
Add something radical like color.
Exactly. That they didn't have back in the 70s, right?
Yeah,
It's a new invention. So let's do that.
Okay. Good. Then, yeah, take care. See you. And yeah, I hope soon we can see other people also sending their experiments.
Yeah, that would be great.
Yeah.
See you next time.
See you. Take care.
Bye.
Bye.